Thank you very much for staying until now to listen to me. I am from, as she introduced me from Norwegian University of Science and Technology. And I will try to present some of the changes we have implemented on enhancing project outcomes in project-based learning. So the aim of the changes which we have introduced was we have actually increased the number of teaching sessions. I wouldn't call them lectures, a bit different. And we wanted to see what the effect will be if we increase this number of lectures, because normally in project-based learning, you want to give the student as much as possible time to do their project. So most of the instructors will have as minimum number of lectures as possible, but we wanted to see if we do it the other way, will it have a positive or negative impact? So what was the background? Maybe we start with project-based learning itself. It's a way of teaching in which the student do things themselves. And it's very good, I would say, because it's very interactive. These ones are engineering students, so by definition, they like doing things. So project-based learning is helpful because they are doing things at the same time they are learning. But it's more real. They feel like they do something. And most importantly, also, is the technology is changing so much. And this is one of the way of ensuring that they can learn by themselves. You can teach it to a certain point, a new thing comes, they can just learn it by themselves. That's why maybe we have projects at the end of the bachelor degrees or master degrees, so that to ensure that the student actually can learn by themselves. But the problem we had, we were doing teaching a course for first-year student, and the only way we thought was good was through project-based learning. But then they are first-year students, so we had some problems. Number one, they don't know anything. Basically, they have background from their secondary school, and sometimes they are not very much into engineering anyway. So the background, they don't have enough background. How can they learn by themselves? That was one of the problems. And the other thing is, if you ask them to do a project, they will find the easiest project possible just to get a credit out of it. And thus defeats the purpose of the whole course. And maybe also they are not used to learning by themselves. They come from secondary school where they have instructors all the time teaching them what to do. So from that, we didn't think it was wise to neglect completely the project-based approach for first-year students. But instead, we thought we need to increase these teaching sessions. They are not enough what we are giving them now. To give them enough understanding of the basic principles so that they can make these projects by themselves. So as I just said before, the root cause was, we will go through the cause later, which cause what it was and how it was taught. But we, at the few years ago, we had only 6 teaching sessions. And after that, the rest of the semester, the students are engaged in their own project. And for a last year student, maybe that's okay. For a master student, that's perfect. But for a first-year student, we were having very low quality. They were not doing things properly. They're taking a lot of shortcuts. And also, the projects themselves were too simple, if I put it that way. So we made some changes and we tried to monitor if the changes we are putting are positive or negative. We had to see. And the aim was, number one, improve their foundational knowledge. They can't do these projects if they don't know anything. Or maybe they will be able to do it, but they will spend a lot of time, which we will see also in the results, what they say about that time they use for this course. And also improve their safe learning ability. If we do that, automatically it will improve the project outcomes. And how are we going to do that? We suggested that we need to double the number of the teaching sessions. So the course itself is called Computer Architecture, which is basically we want to teach the students literally how the computer works, how the bits work. Not the computer does 1, 2, 3, but it moves this electricity from here to here to here to here. And we thought we could give as much lectures as we want. It's difficult to comprehend it if they don't do something out of it. So we were teaching this course. We try to find the most stupid computer there is, because if you take a real computer, it will have a lot of layers, which makes it very friendly to human interaction. So we took the basic one, no operating system on it, and they should command it to do what they want. And how they can command something this dumb, they have to understand it. And that's why we were teaching it in a project-based. So we teach them how this computer works at the basic level, and then they have to do a project on it to this tiny computer without operating system, so that they can understand how it really works without any layers on it to support human interaction. And this is what we had before, our 6 sessions. The tiny computer is a microcontroller, so we introduced it. This one can take up to 48 different input and output. It's complicated enough, I would say. It can take input, output. It can take some signals. It can put out some signals. But as we take a look deeply on this structure of this course, and we can see, for example, on lecture number 4, there are 3 different blocks. They are being taught in these 3 hours. We felt like this is too dense. And then when we talk about a computer, now we talk a computer and a screen, but the computer is only what's inside. The screen is an external part. So here we try to teach the external part, LCD screens, but only one external part. Maybe we should add another one as an example, as computer connects with a lot of things. We also, for example, we have this very important block of analog to digital conversion, which is basically everything in this world is analog, more or less, but our systems are digital. How do we get everything inside a computer where outside is analog and inside is digital? This is the most important part, because at the end of the day, the computer has to talk with someone, or it has to communicate with the environment, but we felt like this was too brief, only one lecture out of this. But also we see that the other part of this is forgotten. You take analog signal from outside and put it in a computer. What about the digital signals, the ones and zeros, which are inside the computer? How do we get them out? This student didn't get time to learn, or they were asked to learn this by themselves. Now, this is what we proposed. Oh, these are the changes we have done to see if it improved. So from lecture 4, out of it, we made 4 separate lectures. each one of them a different one, but we also add, instead of only LCDs, you can connect your computer with screen, but we also connect a computer with a motor. This is a very practical example. We open doors every day, computer controlled. So the motor will open the door, close it, etc. When you tap your card, etc. Some of the students have done this project at the end, where they made a lock, you tap, it opens the door, you go in. And it's impressive for a first-year student, to be honest. Lecture 5, we spread it in 3. Taking in signals, we extended it, and putting out 1 and 0s from computer to the slides out there, we made a lecture out of it also. Or I should call it a teaching session, not a lecture, because it's not a typical lecture. And then we had one session for communication. This serial I/O is basically USB. Our computer communicate with USB, but communication, we have a lot of communication protocol inside a computer, so we add another one, very useful when it comes to sensors. We call it I2C. And we expected the student to learn others, Bluetooth, internet, Wi-Fi, etc. They could learn by themselves. We also added other changes to improve this. Number one, instead of having traditional lectures, we went through a lecture, which is very short, and then we have guided task, where they had a task to do, but it's well guided. They don't have to research anything, just have to get the thing working. Well guided, and we had assistant in the classroom moving around, assisting them. And this helps a lot to build their confidence. I can do this. It's that's kind of feeling it gives. The other thing which we have implemented is make sure that we integrate assignment with more than one module, so that they can see that these things connect. You cannot make a real electronic project with one computer block, basically. It uses more than one computer block, so they see this in the assignment that, okay, here, this assignment, I'm connecting this and this and this, and at the end it works. So that when they get to the project, they can take the same approach of connecting. And then we, of course, that downside of it, if we are going to have 12 lectures instead of 6, we are cutting the time from the project. And this is not ideal. Now we ended up with 6 weeks. It's not ideal. I would have preferred to have more. But we have, this course is taken by military students. So sometimes they come to class. Sometimes they go in a shooting range, and you don't see them for 3 weeks, for example. Especially in winter, they have to train outside and get used to the cold, etc. After implementing these changes, we took the course. This is the 3rd year, maybe, or the 2nd year, which we have taken this new approach. How are we going to evaluate if it's good or bad? Number one, grades. Of course, student change, so it cannot be only grades. Maybe that year the students were just lazy. Another year the students were very good. And then I praise myself from the changes. Wouldn't be fair, I would say. So we also had a survey, which we give every year after the student do their exams. We give them the survey, they do. And there are some questions which we thought they are really related to this change. So we use them. And also, after we implemented these changes, we added some more questions, which we thought are good indicators of positivity or negativity of the change, the impact. So from now on, I'm going to show you some results of the changes. We start with a comparison. This was for results and their grades. And the orange is after the changes. We can see the whole thing shifted to the right. I am sure this is partly to do with the student. Maybe that class was better anyway. But this big change, it has to do also with the changes we have implemented, I would say. So in summary, more than half of the students got B or A. And this was passing the marking through external examiner, not only the teachers of the course. So we are really confident of improvement in the project quality and target. They were not doing small things anymore. Not somebody passed, the light goes on, finish. They were doing something really concrete, I would say. And what's more interesting for me, even before we were getting students who are getting A's, obviously, but what's more interesting to me is on the lower side, we see a lot of improvement on the lower side, where we have B or lower grades 50% before. There, 2024, we went down to 10%. So a lot of people did big projects, basically, since this is the grades they get is mostly from the projects. We had some survey questions. This one, this question we can compare because it was asked before the changes and after. And I wanted to indicate here, you can see the lecture, the student were asked, do you learn which which activity you learn mostly from? Which activity you learn mostly from? And you can see from here, lecture is 6% only, and it has moved up to 20%. It's a big. And what's more interesting for me is the project 17, it has gone up as well. So because they've learned in the lecture a lot, now they can learn even better in the project. That's what's interesting. And the self-study, it has gone down a bit, but it's still significant. It's still 20%. But the other question which we could compare was the workload. Because there are students who get A still, there are students who get B still. But they work too hard, I would say. And other students are not willing to put that much effort, basically. And this is a 5 ACT credit course. I wouldn't complain if they don't put enough effort. So 65% were saying this is too much. Shouldn't be that way. After the changes, only 30%. Half of them now they think it's okay. It's not a big deal. So to summarize these two questions, you can see from B upwards, 3 times the number has increased. Learning activity is important. 3 times they think lectures are important. And students who find the workload is too much have gone down by half. We had other survey questions which were only asked after, because our survey question before didn't involve this kind of questions. Number 1, did you gain any confidence from the lectures or I would say the teaching sessions? And 80% of them, they agree. From the teaching session, they believe they could do projects. Did it make it to learn by yourself easier? 85% agree. But this was more interesting for me. Okay, because we don't want to remove that part of learning by yourself. If we would just wanted to teach them everything, we would have increased the credits, maybe put it to 7.5 and put some more material. But it is important they learn by themselves because these things change all the time. And we can still see 84% they still learn new things by themselves after the lecture, during the project phase. And they could learn it better. They didn't find the load was too much just because we increased the number of lectures. So what do we learn from this? Very important. If you are going to use project-based learning in engineering, very important. You need to give them the basic, and it's specifically for engineering knowledge because it's high rate. You cannot start from top to bottom. And when they learn by themselves, you are not sure where they will start. That's the thing. So as we have seen from our results, although we more teaching, give better project, we are not saying you should always double. It depends on your course. You need to take a look at it and see that you're providing all the basics needed. How do you build the confidence? This is a theory which is already there, but our project also agrees with it. That from our teaching session where they had their guided task, the student from the survey agree that they have more confidence. They learn new things during the project phase, a lot of them, and they made better project, although the time was shorter. So to conclude, we can say that instruction design is more important than the project time you give the student. You need to structure your course, even if it is project-based learning, so that to make sure that the student have enough foundational knowledge before they can take this task of doing the projects. What is left? Maybe we need to follow up on the results continuously and improve continuously. Like, for example, this year I've noticed students are using AI a lot in coding. So I'm waiting for the results. Will it impact positively, negatively? The good thing about it, we have the projects, which the coding can be helped with AI, but then we have very small, short exam, just asking the fundamentals of computer architecture, just the minimum basic. So from this, just to make sure that, okay, they can make things happen, but at least they understand the basic. How does it work? Thank you very much. If you have any questions.